Hi, my name is Omar Santos, and I would like to welcome you to the Big Data Analytics for Cyber Security Meetup. We're a group of engineers, scientists, and cybersecurity professionals in the Research Triangle Park area in North Carolina. The main purpose of this meetup is to learn from each other, share ideas, and more importantly, have fun. You can always get more information about our meetup at the link at the bottom of the screen. Today, I would like to introduce Grant, who is the Senior Vice President of Engineering and the CTO of LucidWorks. He's also one of the major contributors of Solr. He's going to give us an overview of Solr version 5 today. So for those of you that are not familiar with Solr, Solr is a scalable and open source search package that is used by many companies in the industry. And it provides a distributed indexing, replication, and load balancing querying capabilities with centralized configuration. Without any further ado, here's Grant.
And then spend kind of the rest of the time talking about some of the things, as Omar mentioned, that are in Solr 5. How many people here are familiar with Solr or Lucene already? Hopefully some of the things that in Solr 5 I can put into the context of big data and security and why you may or may not care about them, okay? Feel free to stop me at any point with questions. So if I'm saying things that, because you're not familiar with search that are, you're not familiar with, just, let me know and we'll go from there, all right? So, yep, I covered that already. High-level overview of Solr in a nutshell, by far and away the most widely deployed search technology on the planet. Obviously, Google and Bing have kind of internet search all wrapped up, mostly Google, but some with others. When it comes to kind of everything else, though, chances are if you're doing a search on a website or in an application or something like that, you're probably using, almost guaranteed you're using Lucene, and you're most likely also using Solr. There obviously are other choices out there, but by far and away, Solr dominates this space in terms of people leveraging the capabilities around it. So just kind of some rough, hey, you're in good company kinds of things around Solr. We as a company employ a bunch of people who work on Solr. We put on a conference around Solr. I'll leave that as the commercial for tonight. I don't have to pay for my trip here since I just live over in Chapel Hill, whereas if I was at someplace else, I might have a little bit more of a commercial, just to make sure I've got that in place. So, you can see household names. I think Bloomberg, for instance, has almost 200 billion documents in Solr. They do millions and millions of queries a day. Salesforce, I think, is probably the largest I know of using Solr. They have last reported almost 300 billion items that are searchable in Solr, including all of the security credentials that go into filtering whether anybody who's doing a search in Salesforce can see that particular item or not. They do something like 6 or 7 million updates a day on that index or on those indexes that they leverage in their environment. Places like Box and Instagram and Tumblr, et cetera, all household names. So, like I said, even if you haven't heard of Solr before, chances are you probably even used it today. You just didn't necessarily know it. So that's kind of the high level of Solr. What is it underneath the hood? I mean, when all of this stuff kind of started with Lucene, Lucene is a set of Java APIs for building out what are called inverted indexes, or building out search infrastructure. So unlike in a database, what you typically have in search is you've got a bunch of content coming in that you need to split up into smaller pieces, words, tokens, whatever you want to call them, and then we build an inverted index out of that. What's an inverted index? How many people have read a book before? You know that little thing in the back that's an index where it says, this word appears on these pages? That's all really Lucene is doing underneath the hood. It's really, really fast at it, and it's really, really smart about it, but at the end of the day, that's what we're trying to do so that you can go and very quickly look up those kinds of things. So at its heart, an information retrieval system is what Lucene provides. Solr then takes and wraps that into a service. Basically, all the things that are programming in Lucene, because it's a bunch of Java APIs, now just either become convention or configuration in Solr. Solr then also provides all of the distributed capabilities for Lucene, et cetera, et cetera. So you might be asking yourself the question, well, when would I use Lucene versus when would I use Solr. In the large majority of cases, you should just use Solr because it already does the large majority of things that you're going to need. And anything that it doesn't, there's a very nice plug-in framework for it. When should you use Lucene? It's really when you need, probably one, you've got a whole team of people who are experts in search, first of all. Two, you need absolute control over every last thing that happens in that system, right? So, for instance, Twitter uses Lucene, not Solr, because the guys they have a huge team that works on Twitter search, right? And they have very special cases because tweets are a certain length, and then the metadata around tweets are also a certain length. And so they can make a bunch of optimizations in Lucene that they can then leverage for higher performance in their environment. Such that at the end of the day, for instance, Twitter gets something like however many documents a second they get in based off of tweets. Those are all indexed and searchable within less than a millisecond on average. They serve, I don't know how many billion queries or millions of queries a day into that whole search system. And in fact, they just announced this past year that previously in the search product, you could only search like a month's worth of tweets. You can now search the entire Twitter archive as well, and that's all in Lucene as well. If you want to learn more about how Twitter does it, go look up Michael Bush and Twitter and Lucene, and he's got a lot of great talks on how they do this stuff at Lucene. So if you need that absolute scale, go there. Beyond that, obviously kind of core to search or core to Solr is the search problem, right? Which most of us, I think, automatically associate with, I'm going to go type keywords into a search box. But at the end of the day, what's really interesting is that search has evolved well beyond that to do a lot of other interesting things. Search engines have been adding a lot of database-like capabilities, for instance. Databases have also been trying to add search capabilities, such that things like faceting, support for lots of data types, cursors so that you can page through your results, things like detecting languages, groupings, and joining, and, kind of dealing with relational data are all now possible out of your search engine. That's not to say, for instance, we're a full-on SQL store. We can't do all of the types of joins that one might do in a SQL store, but you can do a lot of them. Also, very capable spatial capabilities built into Solr. In fact, I will put Solr spatial capabilities for doing point-based search and all of that up against PostGIS and anybody else in that space any day of the week, and we will win. So that being said, a lot of good stuff in here. At the end of the day, like what you're starting to see, and I think this is where I'll tie it into security, is people, when we think about all the data we have in these big data environments, it's a mixture of a lot of different things. People think, oh, search, that's for text. That's for me going on Google and finding web pages. They don't think that what I really have at the heart of my problem is a ranking problem. Right? I need to know right now what's important in my data. And that's what a search engine is really, really good at. What is important in my data? And the way it figures out what's important is by ranking your content. And all of this inverted indexes and all these structures in Lucene are all geared towards helping you find what's important and helping you put in the features and the functionality that then can produce those things like your top 10 results, your top 20 results, et cetera. And unlike in the past where it was just all about text, like I said, we can deal with numbers, we can deal with spatial, we can deal with enumerated types, you can plug in your own types, and at the end of the day, oh, by the way, yes, we can still do text, right? So this is all very, very good. And so one of the things you're seeing out of this, for instance, is people leveraging search engines to look at their logs. The old days you did grep. This little tiny company came along called Splunk and said, hey, what if we took all those logs and made them searchable and added IT operations around them and stuff like that? Well, guess what? Underneath the hood of Splunk, a search engine, right? It doesn't happen to be Lucene for some reason, but, they made their own choices and went from there, right? And so what you're starting to see is more and more people are mashing together lots of different data types, logs, and a lot of the security stuff being a good example of those kinds of things. Anybody have any questions on kind of the high level or what any of these things mean? Faceting, people familiar with faceting? This is like when you go to Amazon, you search for TVs. On the left-hand side, it says there's 27 Sonys, 13 Samsungs. And so, you think about it as you did an ad hoc query, and the engine is automatically helping you refine down your results without you having to type in or guess additional terms to search on, right? Because maybe you didn't know there was a Samsung TV. Maybe you searched for a 50-inch LCD TV, and you didn't know that Samsung made 50-inch LCDs, and you say, oh, I like Samsung, I'm going to go choose that one, right? Of course, that can apply to security. For instance, you can look at all of your events that are coming in from all your different systems and search them and start slicing and dicing them, and you're giving more power to your users who know how to work with a search interface. They don't necessarily know how to work with a SQL interface or write code or any of those kinds of things. So at the end of the day, I often feel like search is democratizing access to data because we all do search every day. All of your employees already know how to do search, so on and so forth, right? So with that, I'm going to actually shift gears here a little bit. Like I said, I went and just did some quick Googling, searching, to find some data sets, and came across this one called from Kyoto University, which is a bunch of data around honeypots that the university set up to try to attract people who are trying to do malicious things on the network. And so I've just got a little demo here set up that I'm going to walk you through. And hopefully all of this will work because live demos are always really fun during talks. So what I've done is I've published this up on GitHub. You saw the URL there. I'll make this a little bit bigger.
For some reason, we cannot see your...
Yeah, you're not sharing that, I don't think.
Terminal.
I'm not sharing. Oh, yeah, I'm not sharing terminal. That's not as important, but I will share it anyways. There you go. So I've just got, and like I said, this is all published. I've just got a little directory here where I've got a little bit of node running. I've got a little script that's going to set up and index some of this data, and I'll show you what these things look like. And then most importantly, I've got Solr 5.00 in this directory. And so I'm going to kick off this little setup script, if I can type. And what this is going to do is extract Solr and start it running all very quickly here. You'll see we'll do this all in under 5 minutes. And then I'm going to create a couple of different collections. Solr has a multi-tenancy capability such that you can have as many collections or logical organizations of your data as you want, kind of the equivalent of a database, in Oracle or MySQL or any of those kinds of things. And then within a collection, I can then go and index a bunch of data, right? So this Kyoto data set, there's a whole bunch of it. I downloaded, I don't know how much of it, and then I went and wrote a little Python script that just sampled some of that data, and that lives in this data directory here. And you can see it's essentially a tab delimited file, a whole bunch of numbers. There's some strings here that look like, unique IDs or things like that, and a whole bunch of other attributes. Anybody see much text in there at all? Not a whole lot, right? So what I'm going to do then is I'm just going to run this little script that is going to start indexing that data. This is all just kind of background. All I'm doing is just saying, hey, here's a CSV file. Here's the headers for that file, because you notice that CSV file didn't have any headers in it. If the headers are in there, Solr will automatically go and create columns for those headers, or what we call fields. Essentially, at the end of the day, Solr has kind of a notion of a document, and then a document has fields. So it's a little bit still kind of text sounding, but it doesn't have to be. A field can be anything that you want it to be in terms of those field types that we support: integers, spatial, numeric, all of that kind of stuff. So you can see all of that went through and is already done. I don't know how many, I think I have like 30,000 rows in here. And so then we can come into Solr and actually do some more interesting things. One of the things out of the box is Solr provides a very simple search interface, and I mean very simple. This is actually rendered right out of Solr. We use the Velocity templating engine. It's one of the response types you can get from Solr. We can also get JSON and XML and various other formats if you want. But one of the nice things is that you can just very quickly come in and build very quick and dirty little user interfaces on that. So you can see things like, in this data set, there's things like source IPs, destination IP addresses, things like how many bytes were sent from the source and from the destination, whether there was any error rates. There's these few things in here called detection, various detection values. Those have to do with whether they did some pre-computing on this database or on this data set to mark whether there was essentially like shell injections or various other things going on. And in fact, if you want, I can point, when you go to this data set, there is a paper associated with it here. You don't need to read it, but essentially it describes what all of the features are that I index. So that's how I came up with those column names, is I just read the paper and said, make a column name out of each of those. Okay. Any questions so far?
Yeah, I noticed that you're using, this Zookeeper that you were getting the data from, or the orchestrator from that perspective. How do you deal with like enrichments, like geolocation, if I wanted to add that to the mix? Coming from...
So Zookeeper, so you're referring to in the startup script, you saw a reference to Zookeeper. So Solr has built into, like, remember I said it has a distributed capability? So we leverage Apache Zookeeper for that, tried and true capabilities around distributed coordination of effort, if you will, in a system, right? Solr relies on Zookeeper for communication between its nodes, right? So that allows us to have, things like a quorum and all that kind of stuff, so we can make sure that we have consistent rights and all of that kind of stuff. The data itself around whether we have spatial or things like that, that's not anything to do with Zookeeper. Solr, when it comes out of the box, you have a couple of options. In this particular case, I'm using Solr in schemaless mode, or what we prefer to call data-driven mode. Other vendors like the word schemaless. I think schemaless is kind of a bullshit name. There's no such thing as no schema, right? JSON has schema. It's just implied by the data, not in the database, right? So Solr, you can start it up and just start throwing data at it, and it will support essentially two different conventions for understanding what that data is. First convention is it can look at the values of the data and say, oh, this looks like a number. I'm going to treat it like a number. This looks like a string. I'm going to treat it like a string. Otherwise, you can also have it use the convention of the name of the field. And so these are called dynamic fields. You can say, oh, the name of this field implies that it's a string, therefore I'm going to treat it as a string. And in fact, that's what I'm doing here. It's often the safer thing to do with your data, especially when you know what the columns are, but you don't want to go and set up an actual schema, because the last thing Solr will allow you to do is say, I have a schema. I want to lock down my instance of Solr to this schema because I want to know whenever I get errors in my data that they violated my schema, which is often what you want in production. So schemaless or data-driven is really great for getting started. When you get to production, lock it down. Trust me, you'll be way happier. You'll have your weekends. You'll have your nights back, all of that good stuff. Because what often happens in schemaless mode, and why I'm kind of down on it, is things that come in, for instance, the first time as a number, as an integer, and oh, that's an integer. I'm going to treat it that way. 3 weeks later when you're in production, oh, I just got a float in for that value, and your whole system blows up, right? Or you can't find it, which is even worse than it actually blowing up. You wish it blew up because then you would get an exception. It's even worse when all of a sudden you say, oh, I can't even find that value. I know it's in there, but I don't know what it looks like. So the spatial side of it just comes from Solr's internal capabilities. There's a bunch of field types, or we call them, or data types that handle spatial. You can do geohashing, you can do lat long, and in fact, what we do is we integrate the Java topological suite, so you can do full n-dimensional modeling if you want. And in fact, there's some really crazy use cases that we can have a beer over and talk about if you want. So that's all well and good. Solr then also has a bit of an admin UI that comes with it that allows you to kind of understand what's going on in your system. So for instance here, I've got a very simple one node cluster up with 3 collections in it, for instance. But if you had lots and lots of nodes running, you would see them all here. I can even come in and pick my particular collection, and then I can see collection-specific things. Most importantly, I can do queries. And as you can see here now, I can indeed get things like JSON out. So if you're a JSON script kiddie and you really like that, you can go use JSON. So digging into this a little bit more, you can see kind of what you would expect. Solr acts a lot like a database. It just doesn't use SQL. So for instance, what I'm doing here is asking Solr to return all of the documents in the result set. And I don't particularly care about the ordering or anything like that. Just go get them back and return them as fast as you can. I, of course, could put in fielded search, so I could say, find me duration with these values. I can do range queries. I can do complex Boolean matches, all of the kinds of things that, you're used to doing when it comes to working with a data platform, okay? Any questions on that so far? Last but not least, what I put together here is, and sorry, you can see also well, I'll come back to this one. What I put together is a little dashboard. This is from an open source project. So if you've heard of Elasticsearch or the Elk stack for this kind of stuff, we think Logstash and Kibana are great. Well, mostly we think Kibana is great. Logstash is okay. Elasticsearch, whatever. They tend to not be as stable as us, but we really like this visualization framework. So hey, it's open source. We went and ported it to work with Solr, and voila, you have this is Kibana running on Solr. We maintain it as an open source project at LucidWorks GitHub. So if you go to our website, you can go download a whole package that we call it Silk, Solr Logstash Kibana. So hey, flattery's what's the saying there? So anyways, what I did was just put together a little dashboard around this stuff that shows you kind of what's going on in the data, like things like the source IPs, destination IPs, the duration of events, so on and so forth. And I could search through this, I can facet on it, I can select these kinds of things and narrow in on specific results. Remember those detection values? Those map to things like malware types, shell injections, and I don't know if that's IDs detection or IDS detection. You guys probably know better than I. And then, I can also do things like full text search here and see the actual values in the data set. I probably need to refresh this. Or maybe not. Maybe it's this thing over here. There it is. So you can see the actual documents behind this too. So just similar to the other screen. And of course, if you like, you can go. There's a bunch of dashboards here. The nice thing then is that you can take and add other panels. If you want to map it out on a world map, we've got some. We've added some of our own panels based off of what we know we can do in Solr versus what they do. So you have various other options around this data as well. So kind of quick and dirty tour of Solr there. Anybody have any questions on any of that?
What are some examples of the dashboards and things you've added?
Well, so like in this example, right, like I said, I mean, I've got full text search panels. I've got a bunch of histograms and facets. Essentially, these are all leveraging the facets underneath. You can do things like world maps, like actually plot spatial coordinates and all of that kind of stuff. Obviously, it depends on what data you have. But like I've done ones where, for instance, in our commercial product that we sell, we have like a Twitter data source that you can just start indexing Twitter off of. You know, that comes with a bunch of geo information and information about retweets and all that kind of stuff. So you can very quickly build up like a social monitoring platform if you want, like literally in you know, less than 20 minutes, you can be up and have your own social monitoring platform if that's your thing. So very easy to build out. This stuff's all Angular too. It's very easy to plug in your own panels. Essentially Angular plus some D3 and jQuery underneath the hood. So that's all well and good. I think I touched on all of these. Up on the GitHub page, I just put together a little README that helps walk you through all of that kind of stuff. So feel free to try that out. Anybody have any questions on that?
Or any questions from the phone?
So as you saw, a lot of different kinds of data types in there, and it gets really interesting when you start to merge together a lot of different resources, right? So you take structured, unstructured, or text-based, et cetera, and you can start to do some really interesting joins and things like that. So with that, then, I want to dig into Solr 5 a little bit more. You've already seen some of this in action, but we'll just kind of go through it fairly quickly and kind of cover some of the highlights and perhaps put this stuff in the context of big data and security a bit more. So you saw already the get started stuff. One of the things we've heard from the community is that, hey, we want this stuff to be easier to start and run. And so we've done a lot of efforts around making sure that you can just download Solr, bin start, bin stop, all that kind of stuff. You can set up a cluster really easily. You can create collections really easily. We used to be very, you know, war-centric, web archive-centric. That's now essentially implementation detail, so you don't have to worry about that kind of stuff anymore if you don't want to run in a container. And then we ship a bunch of stuff for making this easy for you to run in your environment as well. I think one of the things that we've been seeing as well is that, you know, there's a lot of people who really like JSON. I often think of JSON as, you know, the XML of now, right? Which is, you know, 15 years ago, everybody was all gung-ho about XML. Now they're all gung-ho about JSON. You know, 5 years from now, it'll be something else. And so one of the things like we try to think about is, you know, it's great for, we want to make sure we handle JSON, obviously, but we also want to handle your content your way. And so we try to be very flexible about what we can take in, and we try to do the right thing with that data when it comes in. So whether that's things like PDFs or Office documents or XML or CSVs or JSON, et cetera, you know, it's that classic thing of you want to be very forgiving of everybody else, but very principled in what you put out, right? And so that's kind of the approach that Solr takes around data. And so, like I said, a lot of it is just you be able to come right in, curl your data or post your data, or you can even go in the web interface and upload documents from there, and it should just go and work, right? That doesn't mean it's going to handle the data exactly how you want it, right? Because depending on the attributes of that data, you know, again, it may make a decision and say, oh, I think this is a string when really it's a float, or just because the very first element is that way, or vice versa, right? But it should try to do the right thing and give you a meaningful error if it can't handle it, right? Along those lines, one of the things we do is we ship Apache Tika out of the box. People familiar with that project? So Tika is a content extraction library that abstracts lots of other open source projects to get data out of various file formats. They support something like 40 or 50 different file formats at this point. So things like Office documents, PDFs, CSV, XML, JPEGs, CAD drawings. The whole goal is to extract content out of that, put it into a structure that you can then go and do something with. It's not a Solr project. It started with the Lucene project, but it's no longer part of it. It's all on its own. It does a pretty good job out of the box. Most recently, the latest release added support for OCR. So if you want to just throw image-based PDFs at it, for instance, should be able to do those things. You do have to install a little extra library there for called Tesseract, which is a really good open source OCR library, various other file formats, and then, like I said, various other ways about just making sure we handle your content coming into it. So those are kind of some of the easy use things that have been happening in Solr 5. There's obviously, a long history of making sure that that stuff is easy to use and easy to get going. Digging in a little bit, probably one of the things I think is most interesting, especially when you start to look at slicing and dicing this data, is this notion of what we call pivot facets and then stats related to those pivot facets. So a pivot facet, if you're familiar with like pivot tables in Excel, right? I like to think of them as kind of as like what if facets. What if I do a search for t-shirts and there are 10 larges and 3 mediums and 2 smalls? Well, how many of those larges are blue? How many are red? Those kinds of things. So you're kind of building up a hierarchy of relationships between different fields in your data, right? So that's been in Solr for quite some time. It's essentially kind of quasi-OLAP cube-ish kind of stuff. Again, I won't claim it does all of those things, but especially for a lot, when you're just kind of, you want to just dig into your data and do some interesting things with it and see what's in it, it can be really powerful. Also pretty powerful for display. So for instance here, in this example, the author is my first level of pivot, and I've got a value of Kaiser Sose. You can see there's 42 instances in this particular document set for Kaiser Sose. And then one of the cool things we've been doing is working on where you can actually take any of the different facet types that Solr supports, and there's a bunch of them like range facets and field facets and other types of queries. You can all use those as facets. We're working on adding so that at any given pivot point, you can hang any of those facets off it, as well as calculate statistics about those facets. So in this particular case, it's saying 42 Kaiser Sose fields, author, and the price, there's a minimum price. The minimum price of all the documents that match those 42 is $12.95, whereas the maximum price is $29.95, right? I can bring that home a little bit more here with the data set that we were working on. So if you remember correctly, we've got all this honeypot data here, and there was things like source address and source and destination addresses. I've got a query here that essentially is saying pivot from the source address to the destination address, and then calculate stats based off of the time spent between those two places. Okay, so the structure here, I'm faceting. It tells me what my fields are at the top. Here's my first field, source IP address. This particular address, I think this ends up being like localhost or loopback or something in the data. There's 7,825 entries for that particular IP address in this data set, this sample that I put together. And then this next one co-occurs with that one as the destination 2,919 times. And then off of that, I'm calculating statistics. You can see like the duration, the mean duration is 2.21 seconds. I believe we're in seconds here. You get things like standard deviations and all that kind of stuff. And in fact, we're working on making all that stuff pluggable so you can plug in any math you want there. The really cool thing about this stuff is I can just go and add, I can add in other fields here. So, let's see, let's try destination bytes as a field. I can pivot off of that one as well. And voila, just like that, I got back, and you can see now pivot source, destination, destination bytes, and then duration, right? So all very dynamic. You don't have to calculate that stuff ahead of time. So these are all pretty cool. If you want to learn more about it, you can go to our blog and read more about it. Was there a question?
Yeah, that is it. Do you know if they got it from like NetFlow data? From
the Kyoto data? It's in the abstract of the.
So if you mentioned that, of course, you leverage Kibana. You also leverage Logstash as well.
Well, in this particular case, there's no Logstash. I mean, you can use Logstash. You don't have to. I mean, all Logstash does is take a log file and send it into the output area as like a formatted message.
So I should be able to plug in things like NetFlow.
Yeah, all of those.
As long as I actually have, that schema orientation.
Yeah, I mean, Logstash has that whole grok, like the mapper thing that maps your log fields to your output fields, right? So, yeah, I don't know where.
I can bypass Logstash. I don't need Logstash to get NetFlow data.
You don't need Logstash for Kibana at all, right? I mean, it's just a convenience for people who are doing logging, right? And it's actually like you're better off probably in the big data environment using like Flume or one of those. Those are way higher performing than Logstash. So, you probably are more along those lines. But you can use I think FluentD. There's Logstash has support for, 30 different input connectors. So, any questions? A bunch of API stuff. Since you guys are new to Solr, just kind of know that, one of the things that Solr used to be very just configuration centric, as in, there's property files and all that kind of stuff. Over the past, 6 months or whatever, we've just basically been adding APIs for everything as well. Such that I think you'll see over time. I mean, I kind of get torn on this one. APIs are great for programmers. There's not always great for your IT ops and all of those kinds of things. It's nice to have configuration files that you can version control and all that, and you don't have to go do a full release every time you want to make a change in your configuration and that kind of stuff. But there are a lot of times where you want kind of that on-demand change in your configuration. So we've added a bunch of those things as well as taking care of a number of other things around API. Underneath the hood, remember I mentioned there's this thing called Lucene, which is essentially Java APIs. Lucene and Solr are all part of the same Apache project. So whenever Solr releases, Lucene releases, vice versa, right? So along with Solr 5 came Lucene 5 as well. And so there's a bunch of really cool things in here. Usually at the end of the day, what comes from Lucene that Solr just gets to take advantage of is that we're almost always making improvements in memory. We're almost always making improvements in I/O speed and all of that kind of stuff, as well as kind of index safety guarantees and all that kind of stuff. In terms of making sure that it's very robust and you never lose data and all that kind of stuff, okay? At the end of the day, that's one of the benefits of just using Solr is you just get like 99% of the improvements in Lucene just by installing the latest version of Solr. Other things that have been really a big focus for us at LucidWorks and in the community is making sure that we can handle all of the scale that you want to throw at it. I think it's really interesting statement about the scalability of Solr and the fact that all of the major Hadoop distributions have chosen Solr as their default search engine of choice, as well as if, for instance, you go to our website, we actually are now powering all of iCloud, for instance, millions and millions of users, petabytes of data, that's all being powered by Solr. And all of these decisions have been made within the last year as to why they selected Solr. And in fact, what I think you're seeing is that Solr scales very, very well. We don't have to re-index all of our content. We can split shards and rebalance. So you can incrementally add nodes, whereas some of our competition, you have to go, once they run out of sharding capacity or distributed capacity, you have to go re-index all of the content. We don't have to do those kinds of things. The Zookeeper stuff gives us way better reliability. So you pay this little bit of pain up front with the fact that the Zookeeper is one more thing you have to install, but you get that back in spades during production when you know what's going on with your system and you don't have split brain issues and all of that kind of stuff. So if you want to learn more about kind of what we've been doing around scale, go to Shalin Malgar is actually one of the guys who works for me. He did a keynote at our conference on a lot of these changes, along with the lead search engineer at iCloud at Apple. So you can kind of go see a lot of the work that unfolds there. A few other things underneath the hood, probably more for people who are really into search. You don't really need to worry about it, but Solr keeps, and Lucene keeps a lot of underlying statistics about your data. And so all distributed IDF does is share this IDF information. You're saying to yourself, what's IDF? In kind of traditional search, just to give a real quick lesson, essentially what Lucene does at its core is what's called a vector space model or vector space lookup. So if you remember your high school math, if you take one vector in a dimension, and that's your document, right? Because a document is a tuple of weights, right, or of terms. So I've got one dimension here, or I've got one vector representing my document. I can do the same thing with my query. What's that form? An angle. I take the cosine of that angle, right? And that tells me how similar these two things are. Cosine of 0 is 1. Cosine of 180 is -1, et cetera, right? So at the end of the day, when what Lucene is doing is, when it builds its index, is constructing various weights that go into calculating what that vector's scale is. A lot of math, I know. What this means is that when you take that stuff and you distribute it across all of your architecture, you then get much more reliable results around what's the most important stuff in your data, to make a long story short. Other things that have been doing a lot of work on, anybody heard of Jepsen? So Jepsen is basically this really nice Clojure project. If you happen to like Clojure, it's really nice. If you don't like Clojure, not so much. But it's basically a chaos monkey type project where this guy, Affer, who's the one who tweeted here, basically he's kind of an evil guy, and he says, what are all the different ways that I can destroy networks and hardware and all that kind of stuff? And Jepsen then simulates those. And so, for instance, Jepsen will simulate network partitions and hard drives crashing and all of that kind of stuff, right? And so he's been working his way through lots of different distributed systems like RabbitMQ and Elasticsearch and various others, and saying, hey, you guys think you know what you're doing with distributed systems, you don't really know what you're doing with distributed systems. Right? Because people often make choices that just are not very good, or they think they're safe, and what often happens in distributed systems is what you think is safe is almost always wrong, right? So what we did is we took the exact same test that he ran against Elasticsearch, which Elasticsearch I think passed 1 out of 5 or 7 or 10 of them. And we ran those exact same tests. We had one minor bug that was fixed within 1 week and a couple of other smaller bugs. Passed all of them with pretty much flying colors. You can go read those here. This is, again, because we chose Zookeeper. Elasticsearch chose to build its own distributed coordination system. I don't know about you, but search is hard enough on its own. Why would I also want to build my own distributed coordination system when there's something like Zookeeper that does it for me? The big trade-off, like I said, though, is Elastic, for instance, can start up and just kind of discover who's in its around it, whereas we can't do that because Zookeeper has to know where your machines are. So like I said, a little bit of pain up front, but way less pain when you're in production, right? So that's kind of the getting finished side, which I think is, at the end of the day, what we're all after, right? We like to go home and sleep and have our weekends and all that kind of stuff. Other various things, a bunch of stability improvements. I think we're always just kind of beating on the system in terms of dealing with data and making sure we don't have overflows from too much data coming in or that kind of stuff. And so that's kind of the core of Solr 5. Any questions on that?
If you didn't know what you were doing, which would be me and this guy, and I started up Solr and I've got all these queries going, people are hitting it, and it's logging more stuff, or I'm using more RAM than I really want. It's a pretty easy to on the fly go in and say, I don't care about this much log data, like where Solr can reset and say, well, I normally keep 100%, now I go down to 75% to 50%.
Yeah, obviously there's some design you want to do in that, but Solr does, for instance, you can set time to live on documents. So common logging scenario would be to either do it at the individual document level, say this is how I want to keep this. What more often happens as you get into more advanced logging scenarios is you set up like kind of a hot, warm, cold approach whereby you have shards by day or by hour or by whatever volume you so choose, and then you age them out of your system such that you drop whole instances all at once as opposed to deleting individual documents. As far as the throttling or dealing with just, large volumes of data coming in, that's just, simply, almost always just simply add more nodes, right, which is, scale horizontally, right? There are various other tricks that you could do in terms of, looking at the data and trying to assess whether it's high value or not, which in my experience almost always fails in the real world because as soon as you throw it away, then somebody wants it, right? But yeah, no, I think it's pretty easy to get up and going. Obviously, building any large-scale distributed system is a complex problem, so I'm not going to sugarcoat that for you, But it is, I think, pretty easy to get up and start throwing data at it and go from there.
Yep. Could you mentioned that the math would be pluggable in some sense. Could you comment a little on maybe the query execution model? Like if I have a very large installation with multiple, servers involved, like where does the computation occur? Am I pushing that down to where the data is stored, or is it?
The large majority of it, I think it's typical, like you try to get candidates that then surface up, so the large majority of the stats and all of that is done locally on each node where the data is. But then if you got to add them together, you're doing aggregations, right? Then somebody's got to bring them together at some point, right? And so Solr takes care of those kinds of things. I think we try to be smart about it, but there may be spots that work needs to be done there. One of the things we're doing in our product, for instance, is bringing Spark in to really leverage really large-scale computations. Solr out of the box is not a distributed compute engine, although there's a lot of aspects that allow you to do some of those things, right? But, at the end of the day, something like Spark is usually often better for that kind of stuff. So that's in our commercial product, though. So, I said I wouldn't do too many commercials today, but that will be coming soon. So. Along those lines, though, I think some of the things we're working on in the future, I hinted at some of these faceting stuff already, bringing in just different ways of, again, slicing and dicing the data, bringing in some via T-digest percentiles and various other ways of calculating estimates. You can often gain some performance at the cost of accuracy in some of these situations, which is often good enough for logging scenarios. I just need to know, is this more than 1 or is it more than 100? I don't need to know that it's 103.2 or something like that. So a lot of distributed algorithms often require 2 passes on the data, but then you can make estimates with only 1 pass. Some various other things, trying to do some more complex joins with the data depending on where it lives. Those are all underway. So just a little bit of a peek at, what we're working on as a company and in the community. And then, right now, Java's kind of as you saw, like everything's JSON and all that and REST-like in terms of the APIs, but a lot of people also like to have clients for a particular engine. So Java is probably the main one that we've always shipped, but we're working on adding more there as well. So things like Python. Well, basically what we're going to do is implement a C-level version that can thus be used in C-based languages. And then the Java stuff can all be leveraged in JVM languages. And then I got to find somebody who does .NET to do that one. So if you want to learn more, various articles, etc. And that's it for me. How are we doing on time?
We're doing perfect on time. And it's just, yeah.
Any questions?
Would there be a possibility to get the copy of the slides or
Sure.
share and then slide
Yeah.
share?
Yeah, that's
I
fine.
appreciate it. And I'll send it to everybody. I know that a few folks were not able to join. I'm recording the WebEx too, and I hope you don't mind if I post it. Yeah.
So I don't know how much you want to get into the guts of Lucene. We did some performance testing with Elasticsearch last summer, And we found our bottleneck was actually in the Lucene layer. It was stuck eating a lot of CPU. We were doing, pretty high level rates of ingest, really detuned a lot of the analysis going in, really small documents. Do you know at the Lucene level if what changes, if any, have been made to improve on some of those things?
I know in the Lucene layer, they've been making a lot of improvements around, especially with small documents, hence log files. The team's been doing a lot there. I want to say many of them are in 5. What kind of ingest rates were you talking about?
We got it up to around 700,000 documents a second with a 8-node cluster.
Nice, yeah. Yeah, I think, I've seen, we just did, we've got a couple of customers that we've just recently done in that range and or higher, so I think you're in the same ballpark. A lot of that stuff really is how fast can you write bytes out and how much analysis are you doing. So if you've tuned all of those things, it's pretty good. I know there's been some efforts around doing smarter things with short documents. There's also choices that can be made around it. Lucene is very pluggable at the I/O layer as well as what we call the directory representation. So you do have some choices there. Some of it may just be limits to Java too. I know they upgraded some of the I/O packages in Lucene recently as well. So I don't get as hardcore into Lucene as I used to, but still try to keep aware of it. If there's specific things, your best bet is to ask on the mailing list for Lucene. If you had specific blockers, you might want to go rerun them with 5 as well.
Yeah, it sounds like we'll just give this a shot with Solr 5 and Lucene 5 and see what that does.
Yeah, at the end of the day, too, sometimes you just simply need more nodes. You do reach the limit of physics in some places. I'm not saying you have, but... Yeah,
I'm not allowed to have any more nodes.
Yeah, we hear that one a lot, too. It's funny because we often get compared to NoSQL engines like Cassandra and all that, but I think, at the end of the day, because you're building an inverted index, you're actually asking Lucene to do more than you're asking just like a database to do if a database is just writing bytes, for instance, and you just need kind of key value retrieval. So, but it sounds like you tuned a lot of that already as well. I think in the log scenarios, I know some of the other logging engines, they actually don't tokenize at all, and then their query time approach is all regex based. And so you're essentially paying the cost for tokenization at query time, which is often a win because your query volume on most logging systems is quite small, whereas your write volume, well, I shouldn't say quite small, it's significantly smaller than your write volume. So anything you can do to speed up writes can be a win at the cost of maybe your queries take, 500 milliseconds instead of, 50 milliseconds. Any other questions?
So if you were to peg Elasticsearch against Solr, what's...
Yeah. No, I get that question all the time. If you paid attention to what they just did this week, they changed their name and now started redirecting the org site to their company site. So in other words, they're taking the open source private, more or less. So I kind of like to break it down into a few things. One is the kind of the cultural aspects of open source, and then the actual code itself. So depending on how you feel about religion, right, and about where you get your open source from, Solr comes from Apache. Apache Software Foundation is a 503c nonprofit, right? They're not going anywhere, right? Even if LucidWorks disappears tomorrow, Apache's still around, right? And so one of the key things about Apache is it's open development, right? Nothing goes in without discussion around it, right? All the JIRAs are all public, all of the commits, all of that stuff is all public. There's, if you're one of their top customers, great, you're on their list and you can get your stuff in. But in fact, I think somebody did a study of pull request history on GitHub, and they were, of all the most popular projects, they were the lowest ranking in terms of accepting outside contributions. So that's the cultural aspects of it. I would put open development much higher than I would put open source, right? Anybody can share their source, but if you don't share how it's being developed or what your roadmap is and why you're doing things, then what difference does it make? Because chances are you're not going to go dig in all of that. So that's the cultural aspects of it, right, or the governance aspects, all that kind of stuff. As well as, I should say, Apache has very clear governance guidelines, whereas I think just recently they started having contributors sign, I give you the rights to use this code. So I'm not a lawyer, but I know I've talked with a lot of lawyers who, if they don't see very clear governance and provenance around the code, they will not let you have it. I can guarantee you, like a place like this, your lawyers think about that all the time, right? Whereas Apache, you know, has been doing open source for a long freaking time, right? You know, I hinted at with a lot of the scale stuff, nobody's ever done exhaustive side-by-side benchmarks. I've seen ones where Solr's faster. I've seen ones where Elastic's faster. At the end of the day, a lot of that stuff comes from Lucene, and they're roughly the same. I do think we actually, and I've seen this from a number of third parties, not even our customers, have come and said, done a bake-off on their own and said we scale better. And a lot of it has to do with the fact that we do the split shards and all of that kind of stuff, and we can rebalance more effectively. The Zookeeper stuff, I have no doubt in production is way more stable than their approach, right? So, like, I think at scale and in production, Solr is way better. Where Solr traditionally has fallen short and has often been where people have gravitated towards Elastic is that kind of getting started experience of, just like with Mongo, and I think Mongo falls into the same trap, right? Download it, boom, got data in, wow, this is a great experience, right? And then, you know, 6 months later, you're like, oh, I've got this in production, it doesn't scale anymore, you know, because like Mongo with the global write locks and things like that, which they're just now starting to address. And then, you know, things like, you know, like if you run out of shards, you got to go reindex your whole data set, all of that kind of stuff. So I think we have a better story on scaling. Feature-wise, toss it up in the air. I mean, at the end of the day, we as a company make our money off of our product, which adds a whole bunch of stuff on top of Solr anyways, connectors for crawling the web, SharePoint file systems, all that kind of stuff. We have pipelines for doing ETL. We have like a whole relevance engine that's geared towards taking in collective intelligence or what we call signals, or feedback from users, and turning that into smarter relevance, all of those kinds of things. But at the core, Solr versus Elasticsearch in terms of features, facets, aggregations, you know, they have some things we don't have. We have some things they don't have. That stuff all ends up being a wash in terms of, in my mind, at the broad level. So,
do you have an equivalent of Shield?
We do in Fusion. That's part of what we sell in our product. We're actually adding more security stuff into Solr as well. Like, so you can Kerbereize Solr and all that kind of stuff. You know, we do authentication, authorization, and encryption all in our product. Solr supports all of that, and then we layer on top of it management and all that kind of stuff. So, yeah, and we've been shipping that for 5 years now. So.
And they just came out with it.
Yeah. So, you know, I mean, your mileage may vary there. They've got a lot more money, you know, perhaps. From venture capital, I don't know. But, you know, the broad community. Solr is also supported by lots and lots of other contributors. So like I said, even if Lucid goes away, IBM's a supporter. I know Cisco's contributed, Netflix, Box, Amazon, on and on.
You mentioned multi-tenant, so we could take a Solr cluster, right? Can you keep separate central data stores, or so I can hold, let's say, 5 very vastly different customers' data, and limit access down to, you know, Joe over here can only see that one.
Yeah, I mean, what you often see in multi-tenant scenarios and hosted, right, is that you want to put as many small customers as you can into one big index, and you want to like kind of lock them down that way. and then you put a few medium customers in one big index, right? And then any of your large customers, they each get their own, and they each get their own cluster often, right? And so you can set that up, you can route accordingly. If you go watch the iCloud keynote from our conference, they'll talk about that a lot. Salesforce does similar kinds of things. You know, you have to be careful when you do that kind of stuff with a search engine. It's very easy to apply filters to your content, but then there's also a lot of ancillary data structures. For instance, if you want type-ahead autocomplete, that, for instance, doesn't take into account those security filters. So you may not want to offer that because somebody could kind of round trip their way into what data they can't see via autocomplete. So you do still have to be careful if you're putting multiple customers in the same index. But you can also have lots of indexes, right? Like, so for instance, AOL Mail, they have collections, you know, one collection. Everybody who has AOL Mail, I know it's not as many as it used to, but it's still millions. Each one has their own collection that runs within one Solr JVM, and then they shard and distribute, right? And they actually, you know, they can put hundreds, if not thousands, of those collections in one JVM instance. They have like loading and unloading mechanisms that Solr supports as well. So lots of cool capabilities there. There's still some things that you really want in a true multi-tenant situation, like making sure that you can very quickly, well, you can move tenants around. That's part of doing multi-tenant, but you also want to make sure that any spike nobody can ever spike to and do like a denial of service on all the other tenants and that kind of stuff. Like Solr doesn't have like that kind of throttling, but usually you can do that in front of Solr anyways. Lots to take in, I know. You go to lucene.apache.org/Solr. You can learn more, try it out, download it, go to our website as well. Any other questions?